Hello everyone, good day to you all. You're welcome. Aisha Bande here. If this is your first time, please kindly click on the follow button and subscribe to this channel. And if this is your first time also, do not forget to turn on your notification bell so you get notified anytime I post a new video or anytime I am live on this page. I welcome you all once more. So if you're writing WAEC, writing NECO, or writing JAM this year 2026, this page is for you. This live session is for you. So we have some physics questions we'll be solving tonight, and we're going to be I'll be picking questions from WAEC, NECO, and JAM 2026. All right, so this session is going to last for, let's say, 90 minutes. Okay, so we're going to get started immediately. Please help me repost this live. Help me reshare this live so we can have more audience. So let's get started. Okay, so to all my examiners, those writing WAEC, NECO, and JAM 2026. So we are solving physics questions. So I'm going to begin with question 1. I'm going to start with question 1. The question here says, so the topic, let me indicate the topic. The topic is under units and dimensions. So let's begin. Let's get started. Question 1 says, the derived units of pressure can be expressed as, so we have options. This is an objective question. Option A says, option A is kilogram meter per second square. Option B is kilogram per meter per second square. Option C is kilogram per meter per second square. Option D, which is the last option here, is kilogram per meter second square. So we have 4 options. So we're going to solve this problem now and find out which of the option has the correct answer. So let's get started. If you're just joining, thank you for joining. Please help me reshare this live so we can have more audience. So let's begin. Solution. So it says the derived unit of pressure can be expressed as. So to begin, the first step, that's step 1, is for us to write out the quantity. The quantity in this question is what is the pressure, right? So the quantity is the pressure. Step 2 is for us to write out the formula for pressure. To solve a problem of this nature, or to solve any problem in physics, you have to know formulas in physics. It is very important. So if you're here and you're just joining, you're welcome. To make the class interactive, please can we use the chat box? Can anyone here on this live, at least at this moment I have 33 viewers, can anyone tell me the formula for pressure? Tell me in the chat box. You can drop your answer in the chat box. What is the formula for pressure? Please, let's make the class interactive. Who can tell me what is the formula for pressure? We are solving physics questions, okay? So the topic we are treating tonight is, we are treating problems under units and dimensions. So we have a question here, and under this question is an objective question that is multiple choice question. We are required to solve this problem and find out which of the option has the correct answer. So the question I asked is, who can tell me what is the formula for pressure? Drop your answer in the comment section. Formula for pressure, anyone? Anyone, please? Okay, since I'm not getting a response, I'll just continue. So the formula for pressure is given as what? Force divided by area. Okay, so pressure is force divided by area. So what we're going to do next is for us to find the units or the dimension or the unit for force. So the unit for force, let's work for force. So the next step now, force. The formula for force is what? Force is what? Mass times acceleration, right? Force is given as mass times acceleration. And what is the unit for mass? Mass is kilograms times acceleration. What's the formula for acceleration? Acceleration is what? Velocity divided by what? By time, right? What we are trying to get is the what? Is the unit of the quantity what? Pressure, right? So this is what? Kilogram times velocity. What's the unit for velocity? Anyone? Can anyone tell me the unit for velocity? Anyone in the chat box? Velocity is displacement over time, right? Good. So velocity is what? Displacement over time. All over, we have a time here. So this is the time. So this is kilogram times displacement is measured in meter over the time here is second, all over. Remember, we have the other time, which is second, right? Okay, so we are doing this step by step. I'm just taking this step by step to show the audience how to break down and get our answers. So now breaking this down, this can be written as kilogram. This is m/s, which is what? Meter per second. All over, we have seconds here. That's the denominator. So this can be written as kilogram meter per second. This line here stands for division, right? So this can also be written as what? Kilogram meter / seconds. Division return to multiplication. And what happens to this? This becomes what? Okay, let's write this way. It's easier this way. This is kilogram meter over s. This is a slash, right? Then divided by this seconds s. So this is equal to kilogram meter over s times division turns to multiplication and the fraction will flip. So we take the inverse of s, which is 1 over s, right? So this is written as what? Kilogram meter. Then the s times s is what? S square. So this can also be written as kilogram meter per second square. Now this is the unit for what? For force. But remember what we are looking for from the beginning is what? The unit for what? Pressure. And pressure is force over area. So now we've gotten the unit for force as what? Kilogram meter per second. Now over area. Area is what? Length times breadth. Or let's solve for the area separately. Then we'll come back and then substitute. We can do it that way too. So we've gotten the unit for force as kilogram meter per second square, right? Now let's get the unit for area. The formula for area is going to be what? Is going to be length times length or length times breadth. And length has a unit of what? Meter. So this is going to be meter times meter, which is equal to meter square. So that means the unit for area is meter square, while the unit for area is kilogram meter per second square. Now going back to the original question. Going back to the original question where we are required to find the unit for pressure. Pressure is equal to what? Force over area. So at this point, all we have to do is to do what? We substitute the unit we've gotten. So we got the force as what? Kilogram meter per second square divided by what? The unit for area, which is what? Meter square. So now what do? We simplify. So this is kilogram meter. This slash means over. That is s square. This is a line of division divided by what? Meter square. Okay, so now this is equal to what? Kilogram. Now the meters here, that is the m, we bring them together. The first m here has a power of 1, right? So over s square, division turns to multiplication. If division turns to multiplication, what will happen? We take the inverse of m square, which is what? 1 over m square. So we keep simplifying, right? So this is equal to kilogram meter over what? S square m square. Now let's break down. 1m here, we cancel 1m here. We have kg over m s square. So writing this, now bringing all the values we have at the denominator to the numerator, this now becomes kg. The m, we are taking the inverse, which is m minus 1. The s also, we take the inverse, which is s minus 2. So this is the unit for pressure. This is how you get the unit for pressure. Kilogram per meter per second square. Okay, so now we go to the options and check which one is the correct answer. Kilogram per meter per second square. So looking at the 4 options given, the correct option is B. So that's how we get the unit for any given quantity. Okay, so in case this is a theory question, this is how you show how to get the unit for the given quantity, which is pressure. Okay, but if it's an objective question, let's say you're writing JAM, you don't have to go through this whole long process. I have to do this so as to solve and break it down. So we see how to solve this. Okay, how to get units of any given quantity. So now let's move on to the next question, which is question 2. It says, which of the following represents impulse? So I'm going to write out the options given in this question. Which of the following represents impulse? Option A is mlt minus 2. Option B, mlt minus 1. Option C, mlt. Option D is ml. So this question, looking at the options given, the options already guides us or tells us where this question is coming from. So this question is not unit, rather this is a question under dimension. Okay, so what we are required to find, or what this question requires us to find, is for us to get the dimension for impulse. So for us to solve a question of this nature, what do we do first? Who can tell me in the chat box? What's the first step? What is step 1? What's step 1? What do you have to do first? You write out the dimension, which is the quantity, which is impulse, right? So the next step, you have to state out the formula. What's the formula for impulse? Impulse is force multiplied by time. Force times time gives us the value for impulse. And force is what? Force is mass times acceleration. So this is mass times acceleration times time. Okay, and already we've gotten the, okay, what we did initially was the units. Now this is dimension. Now this is mass. So we write this out. Mass times acceleration is what? Velocity over time, then times the time we have here, right? That's how we keep breaking it down till we get the answer. So now this is mass times velocity. Here is what? Displacement over time, all over the time we have here, then times another time. So I'm breaking this down step by step, step by step. Now let's introduce the dimensions. The dimension for m, which is mass, the dimension for mass is m, times the dimension for the d, which is the distance or displacement, is what? Can anyone tell me? What's the dimension for the d, which is the distance? Dimension is L. I'm not getting a response. I'm not getting any response from audience, and I have viewers here. I think making the class interactive is when you guys, try to chat with me in the chat box. It's just a way of supporting this live session. So the dimension for distance or displacement is length, over the dimension for time is what? Is t. Then times the dimension for the time here also is t. Please do not forget, you have to put all the dimension in an enclosed bracket. Very important. It has to be in an enclosed bracket. Okay. Okay, so now let's simplify this. This becomes m times L times T will give us m, or we can decide to write them all in one bracket, in one enclosed bracket. This is MLT in an enclosed bracket, all over, we have T as denominator, right? So we have ML over T. So this is what, so explaining again, force is mass, force, we are looking for the dimension for impulse. Impulse is force times time. And we know that force is what? Mass times acceleration. Then we have the time here. And we also know that acceleration is what? Velocity over time. And velocity, so we have mass times velocity over time times this time we have here, right? Then this is the mass times velocity is what? Velocity is what? Displacement over time. All over the time we have here, then times the last time here. Taking this step by step. So now what we are doing is what? We are just trying to introduce, the words dimensions. So let me show us what I did in this step here again. Remember, we have a T here, we have another T. In fact, from here, the T here can cancel the T we have here. Yes, to simplify this. So we're going to be left with M times D, then, okay, M times D divided by the T. So now let's introduce the dimensions, right? So the dimension for M, which is mass, the dimension for the mass is M times the distance or displacement. The dimension is given as is what? L, all over. The dimension for time is T. So simplifying this, we have M times L. This is ML all over T. This can also be written as what? ML times the T here is 1 over T. So this is also equal to ML times, now let's take the inverse of 1 over T. This is going to be T to the power of minus 1, right? So this, the final answer is MLT minus 1. So this is the dimension for impulse. The dimension for impulse, MLT to the power of minus 1. All right. So this is an objective question. So the final correct answer is option B. It's so easy, just as easy as that. Okay. So do we have any question before I move on to the next one? If you have any question, kindly drop your question in the chat box before we move on. We are solving questions under, under units and dimensions. Okay. We are solving questions under units and dimension in physics. If you have any question, drop your question in the chat box before I move on to question 3. If there is no question, then I will just move on to the next question. So question 3 here says, which of the following units is equivalent to what? So we have 4 options. This is an objective question as well. So the first option is kilogram meter per second square. Option B is kilogram meter square per second cube. The third option is kilogram meter square per second square. Then the fourth option is kilogram meter square per second. Okay, so these are the 4 options. So let's get started. So the solution, which of the following units is equivalent to what? We are looking for which unit is equivalent to what. First, for us to solve this problem, we need to ask which quantity has a unit what. What's that quantity? The quantity is what? Power, right? So since we now know that the quantity is power, what's the formula for power? Power is equal to what? Work divided by time. Or power can also be said as what? Force times velocity, right? So this is the formula for power. So we can use force times velocity. So this is power is equal to force times velocity. I will know that force is what? Mass times acceleration times what? Force is mass times acceleration. Then we have times the what? The velocity, right? And velocity is what? Displacement over time. Okay. So what do we do next? What do we do next? Now we have all the quantities. I mean, we have the formulas. So this is mass times acceleration times what? Displacement over time. So this is also equal to what? So this is also equals to what? Force is mass. We have acceleration here, right? And we know that mass is what? Mass is kilogram. Okay, we also have to write out the formula for acceleration. Yes, we also have to write out the formula for acceleration. So this is going to be mass times acceleration is what? Velocity over time, right? Then times d over time, which is this formula. Please hope you are getting it. Please let's chat me up in the send me a message in the chat box in case you have any question. Okay. So acceleration is velocity over time. So this is equal to mass times velocity is what? Displacement over time over all over this t. Yes, then times d over t. That's how we keep working and simplifying, right? Okay, so let's see what we can cancel out here. So we have m times d over t. This line here is division divided by t, then times d over t. This can also be written as m times d over t. From our knowledge in mass, this division turns to multiplication. What will happen to the t? We take the inverse, which is 1 over t, then times d over t. So what do we have here? What do we have here? So here we have what? M, then we have d times 1 times d, which is d square, right? All over t times t, which is t cube. So now we can write out the dimension. This is mass. Mass has a unit. Okay, this is not a question on dimension. This is a question under what? Units. This is units, right? So let's write out the unit. The unit for m, which is mass, is what? Kilogram. This is distance. Distance is measured in meter. That is meter square. All over t to the power of 3. That is time. Time has a unit of what? Seconds. That is s to the power of 3. Right? So now let's write this out. This is kgm to the power of 2. This is division divided by 1 over s to the power of 3. Right? So this can be also be written as kgm square. Inverse of 1 over s to the power of 3 is what? S to the power of minus 3. So this is kilogram meter square per second cube, right? So this is the units for what? So this is on units that is because the question says which of the following units is equivalent to what? So the units equivalent to what is kilogram meter square per second cube. So let's look at the options. Which option has the correct answer? Kilogram meter square per second cube. So option B is the correct final answer. Nobody has asked me any question in the chat box so far, so that means all of my audience here understand what I have been teaching so far. If you have any question, please kindly drop your question before we move on to the next one. This is this session will last for like, let's say, an hour. Yes, it's an hour session. We spent almost 30 minutes on the live. Thank you all for your engagement on this live. Please kindly support me by liking this live. You like the live, you help me to reshare the live. And aside resharing, another way of supporting me is also following or subscribing to my page and turning on the notification bell so you get notified anytime I post a new video or anytime I am live on this channel. All right, so do we have any question before I move on? Any question, please? We are solving physics questions tonight, not math questions. Please, any question? If you have your question, please kindly drop the question. Your engagement is what keeps me going on the live. You know, the more engagement I have, I am It makes me want to stay more on the live. Please, guys, you guys should please support me. Please support me. Please show me your support, please. Please show me your support. So I'll be moving on to the next question now. I'm waiting on the live to see if there's any question from the audience. If you have any question, please kindly let me know. Drop your question in the chat box, please. So I'll be moving on to the next question, which is question 4. Question 4 says, the period T of oscillation of a simple pendulum depends on the length L and acceleration G. So we are required to determine the exact form of the dependence. Okay, so let's get started. The period T of oscillation of a simple pendulum depends on the length L and acceleration G. Determine the exact form of the dependence. Please, guys, let me know. Is my video clear? Is the audio also clear as well? Please let me know in the comment section. Please let me know in the chat box. So let's get started. I'm not getting any comments yet. Okay, so the first step is we are going to establish a relationship between the given quantities. So the relationship, it says the period T, so this is going to be T is equal to, of a simple pendulum depends on the two quantities L and G. So we have L and we have G, right? So the L is going to have a power of X and the G has a power of Y. These are the constants, right? X and Y are constants. So what we're going to do next is we'll express all the quantities in the form of their dimensions. Remember, the dimension for T is equal to T. Dimension for L is equal to L, while the dimension for G will be equal to what? Can anyone tell me in the comment section? We have to find the dimension for G. That's acceleration due to gravity. So let's find out. What's the unit for the acceleration due to gravity? It is meter per second square, right? So now that means the dimension for meter per second square will be what? This will be M will be what? Can anyone tell me in the chat box? Since acceleration is meter per second square, so what will be the dimension? What will be the dimension? So the dimension will be what? Meter, that is L, length, right? Per second square, that is seconds, that is T to the power of -2. So this is the dimension for T, L, and G. So all we have to do at this point now is just to substitute. Substitution is the next step, okay? Please, if you have any questions so far, please drop your question in the comment section. Thank you all for your engagement. To those that have stayed on my live, thank you. So let's continue. Okay. So we've already established the relationship. This is the relationship, right? So this becomes T is equal to, okay, now that's the dimension for T, which is this T, equal to L. L is what? L is L to the power of X times G. The dimension for G is LT minus 2. Then we have a power of Y. If you understand what I just did, or if you don't understand at all, if you don't understand what I did now, just let me know in the comment section. Let me know. All I just did was to substitute their dimensions, okay? I just substituted the dimensions at this point, right? Are we clear? Okay, so let's continue. So this becomes t, right, is equal to L to the power of x. Then this L to the power of y. Then t to the power of minus 2 times y, which is minus 2y. So now we have t is equal to, now this L, they have the same basis. So we are just going to introduce or use the rules we know from indices, right? So the bases are equal, pick one of them, then we add the powers, that is x plus y. Then we have t to the power of what? Minus 2y. So now looking at this, if we now we're going to compare the left hand and the right hand side. Okay, so on the left hand side we have t, but we don't have L. So what do? We introduce L, and the L is going to have a power of 0. You know L to the power of 0 is 1, so it doesn't change any value, right? And then we have the t. This t has the power of 1 here, right? This is equal to L to the power of x plus y, t to the power of minus 2y. So at this point, all we have to do is to do what? We can now equate the powers. Okay, so the L has power of 0 equal to, on the right hand side we have x plus y. So we call this equation 1. We call this equation 1. Then now to get equation 2, go to the t. The t has a power of 1. We equate it to what? To the power of t on the right hand side, which is what? Minus 2y. So we call this equation 2. So if you understand how we got equation 1 and 2, type understood in the comments in the chat box. Or just type 1 in the chat box if you understand. Type 1 in the chat box if you understand. Type 1 in the chat box if you understand. So now we have gotten our equation 1 and also we've gotten equation 2, right? So that means at this point now, what do? We can now get our values for x and y. So to get the value of, it's easier for us to get the value of y from equation 2. So we say from equation 2, right, we have 1 is equal to minus 2y. To get the value of y, what do? We divide both sides by what? We divide both sides by minus 2. So minus 2 cancels out here. So we are left with what? Y is equal to minus 1 over 2. So we've gotten what? We've gotten the value for y. Now what we need to do next is to get the value for x. So to get the value for x, we say from equation 1, we have that 0 is equal to x plus y. But we already have the value for y, so we can substitute in here the value for y. So this becomes 0 is equal to x plus y, which is minus 1 over 2. So this becomes 0 is equal to x, plus times minus is minus, then we have 1 over 2, right? So collecting like terms, let's bring the x to the left hand side. This becomes 0 minus x is equal to minus 1 over 2. 0 minus x gives us what? Minus x. This is equal to minus 1 over 2. So we cancel out the negative on both sides, right? So we have x is equal to 1 over 2. So viewers, as you can see now, we have the values of x and y. Y is minus 1 over 2, x is 1 over 2. So it's clear, right? So we've gotten the values of x and y. Now we come back to the relationship we've already established. The relationship is what? T is equal to L to the power of x, g to the power of y. So now we're going to substitute in the values of x and y we already have. So t is equal to L to the power of x, and we've gotten x as what? 1 over 2. And g to the power of y, Y is what? We got our Y as minus 1 over 2. So we have minus 1 over 2. We know that from indices, if you have a to the power of half, this can also be written as what? Square root of a, right? So we're going to use the relationship, or we're going to obey this rule. So this becomes t is equal to L to the power of half is the same thing as saying square root of L times g to the power of minus 1 over 2 can be written as 1 over g to the power of 1 over 2. So this is t is equal to square root of L times 1 over g to the power of half is what? Square root of g. So this is equal to square root of L times 1 is square root of L. So we can just open up one big square root and put the two values L over G. So simplifying, so this means our answer T is equal to the square root of L over G. And this is the final answer. So this is the exact form of the determinants. T is equal to the square root of L over G. Please hope you're clear. So if you understood, for those that have been with me from the beginning of the live, if you understand what I have explained, kindly type understood in the comment section. Kindly type understood in the comment section. That is if you understand what I have explained. Kindly type understood in the comment section. If you have any question, please kindly drop your question. Okay, Adeola, you just joined. Okay, you're welcome. I'm solving past questions in JAM. Yes, physics. So I'm solving questions on the unit and dimension. So if you have any question, please kindly send in your question in the chat box. Adeola, you're welcome once more. This session is for 45 minutes. 40 minutes. So I have just 3 more minutes to go. So I will just use the 3 minutes left to complete the 40 minutes to have a recap of what I have done, because I'll be going to another page to hold another live session. Okay. So we are able to solve about, let me see, I think we solved about 4 questions tonight. Yes, we're able to solve 4 questions tonight. The first question says derive the unit of pressure, or it says the derived unit of pressure can be expressed as. So the first question is a question under pressure. The first step is for us to get to write out the formula for pressure, which is force over area, and we know that force is mass times acceleration. We also know that mass has a unit of kilograms, which is what we have here. Acceleration is what has a formula, which is velocity over time. So this is kilogram times velocity is what? D over T. That is displacement over time, or distance over time, all over the time we have here. So I simplify this. So this is kilogram times displacement over time. The displacement has a unit of m, right? Yeah, I'm doing a review now, Adeola, okay? So displacement has a unit of what? Meter. All over. The time has a unit of seconds. All over. That is this line here. The time here, which is seconds. So bringing this together, this is kg. Kg times m is kgm. Then this slash here is this line of division here, right? The second. So this is kilogram meter per second. All over this second we have here, which is what we have at the denominator. Okay, so we have kgm. This slash here is division. I have it here. Then this line here is the division, which I have here, divided by s. So I have kilogram meter all over s. Division turned to multiplication. In maths, if you have a over b divided by c over d, this can also be written as a over b. Division will turn to multiplication. Then the fraction will flip. That means the numerator becomes the denominator. Denominator becomes the numerator. So this c over d now turns to what? D over c. So that's the same thing we did here. This is s. The inverse of s is what? 1 over s, right? So this is kg, kilogram meter over s times 1 over s. So kilogram meter times 1 is kilogram meter. That's what we have at the numerator. Denominator is s times s, which is s square, right? So simplifying this is kilogram meter. This line here is the division line, which stands for this slash here, which we call per. This is kilogram meter per second square. So this is the unit for force. But the question is asking us the unit for what? Pressure, not for force. And pressure is force over area, right? So what I just did here, I've gotten the unit for force. Next is to get the unit for area. And area is what? Length. Length times breadth or length times length. Length is measured in meter. That is L times L, which is m square. So this is the unit for area. So all I just did in the next step is to substitute. Pressure is force over area. And I already have the unit for pressure, which is kilogram meter per second square, divided by the area, which is what? Meter square. So what I did at this point is to do what? To simplify. This kilogram meter slash second square is same thing as kilogram meter over second square. Okay? Divided by the m square. This line here is the division here. The same thing from this rule I explained earlier. So we just obeyed. We just use the same rule here. Right? So kilogram meter over s square. Division turns to multiplication. Fraction here we flip, or you take the inverse of m square, which is 1 over m square. I'm just having a recap for those who are just joining. So this is kilogram meter over what? That is kilogram meter times 1 is kilogram meter. All over s square times m square is s square m square. So the meter cancels as one of the meter here. You know, m divided by m square means what? M over m times m. So 1m cancels 1m. We have 1 over m left. So that's why we have the m here as the denominator. So this is kg all over m s square. So this can also be written as what? At the numerator, we have the kilogram. Then for the meter, m here, we take the inverse of it, which is m to the power of minus 1. Because this kg, this is kg. This can also be written as kg times 1 over m times 1 over s square. So this is the kg here, right? Then 1 over m is m to the power of minus 1. Then 1 over s square is s to the power of minus 2. So we have kg m to the power of minus 1, s to the power of minus 2. So this is the unit for pressure. What we are asked is for us to derive the unit for pressure. So it's just like proving how the unit for pressure is gotten. So that is kilogram per meter per second square. So this is the unit for pressure. If I was in an exam situation, I wouldn't have gone through this long process, but because I want to explain and show us how to go about this, for us to have that knowledge. That's why I'm breaking it down step by step. But if I was to solve this in an exam condition, just 3 steps, I'll get the final answer and pick the correct answer from the option. So the reason I'm doing this is for us to get that, get that knowledge and understand why it is like that. Okay, so the second question I solved, the question says that's question 2. The question was actually on that dimension, because looking at the options given, we have MLT. I will know on the dimension we have the M, the L, and the T, right? So the question said, which of the following represent impulse? For us to be able to solve a question of this nature, to tackle this kind of problem, first we need to find out, we need to ask ourselves, what is the formula for impulse? If you do not know the formula for impulse, or you can't remember the formula for impulse, then solving this question might be a challenge. So that's why I wrote step 1. First, you write out the quantity, which is impulse. You write out the formula for impulse, which is force times time. Please remember your formulas. Formulas are very, very important in physics. Now, we know that force is what? Mass times acceleration. This is the mass. This mass and acceleration is the formula representing the force. That's how we keep breaking down. We're just breaking down, right? Then remember we have the time here, which is this time. So the next step, we have mass times acceleration is what? Velocity over time. velocity divided by time, then times t. That's the t we have here. Now I break down again. I ask myself again, what's the formula for velocity? Velocity is what? Displacement over time. So I'm left with mass times displacement over time, all over what I had, the time I had here. Don't forget this time here. Then times time, which is t. Right? So what I did at this point is the t, the denominator here, the t here, this is just like saying m times d times t is m dt all over t. That's the denominator, right? So the t cancels out here, which was what I did here. T cancels out this t. So what am I left with? I'm left with m times d, which is this m times d all over t. So the next step, I introduce their dimensions. The dimension for meter is m. You know dimensions are written in upper cases, right? Then times the dimension for displacement or distance is L. All over the dimension for t, which is the dimension for time is t. So m times L, ml all over t. This is equal to ml times, this t is the denominator, it is at the denominator, right? So this is same thing as saying 1 over t. So simplifying, I have ml times 1 over t is same thing as saying t to the power of minus 1. So multiplying together, we have ml, then t minus 1. So this gives us the dimension for impulse, okay? So this is not units, this is dimension. So we should know the difference between what? Dimension and units. This question is on the dimension. So looking at the options given, option B is the correct answer. For those who are just joining, please kindly note that I'm solving physics past question in JAM. And the questions are not only from JAM, they're also from WAEC, that is WASE, and also NECO. Okay? So I'm having a recap of the questions I've solved so far. So hope you understood. Hope you understand this. Hope you understand at this point. Hope you understand at this point. If you understand, just let me know in the comment section so I can move on to the third question. Or should I move on to the next question? So the third question we solved here said, which of the following units is equivalent to watts? Already, unit has been mentioned in this question. So since unit has been mentioned, that gives us a guide for us to know that, okay, this question is not under dimension. This question is under what? Units, not dimension. Once we hear dimension in a question, or you see the options having m, l, and t, this is dimension. But once you are seeing meter, you are seeing kilograms, you are seeing seconds, you are seeing Kelvin, all of these are units. Okay? But the dimensions are what? MLT. So we are asked now to check out of the 4 options given, which of these options has an equivalent unit for watts? Remember, I always mention this in my physics class. You have to know your formulas in physics. If you can't remember a formula in physics, sometimes if you know the units will now guide you. The units will guide you for you to know the formula. That's one interesting thing about physics. If you can't remember formula and you can remember the units of that quantity, believe me, if you know what you're doing, then that unit will give you a hint for you to know what the formula should be. All right, so formulas are very important. Formulas are very important in physics. Units, knowing the units of any quantity is very important. Know if a quantity has a dimension or has a unit, or is dimensionless or unit, or doesn't have a unit. It's very important. So now let's continue with this. Now the question here is about watts. Watts is not a quantity. Watt is a unit. So what is the quantity for watts? That is, what is that quantity that has a unit? The SI unit for which quantity is what? I stated it here, power. If you don't know that the unit for power is what, how will you be able to tackle this question? You will be stranded along the line. You won't know what to do after this. Yes, I do stoichiometry in chemistry. I have a page, Aisha Bande Chemistry, on my second page, Aisha Bande Chemistry. But I've not, I can't go live yet on the page because I've not gotten the required number of subscribers. But I do live sessions on TikTok. That's a black app. But you can also search here on YouTube, Aisha Bande Chemistry. Yeah. No, 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 not today. Not today. Not today. So let's continue. So we know that power is equals to work divided by time, or power can also be given as what? Force times velocity. So now we use this formula, force times velocity, to solve this problem. Force is what? This mass times acceleration is the formula for the force, while displacement over time is the formula for velocity. So this becomes mass, this is the mass, times acceleration. Acceleration is what? Velocity over time. Times, then we have displacement over time. So we keep breaking down. So this is mass, m, times, now this velocity also has a formula. And the formula for velocity is what? Displacement over time, all over t. That's the t here we have already. Please don't forget this t, very important. So you don't think the t is for this one. No, this d over t is for velocity alone. Then times d over t. All right, so this becomes what? M times d over t. This line here is division, that's why we have this division here, divided by t times d over t. So this becomes m times d over t. Division turns to multiplication, and we take the inverse of t, which is 1 over t, times the d over the t here. So now what I did was to multiply all the values, or all the quantities I have at the numerator. M times d times 1 times d. This is what? md, m times d times d. D times d is d squared, then times 1 is still md squared. All over t times t, t squared. T squared times t, t to the power of 3. So now I have md squared over t to the power of 3. So what do I do next? Introduce their units. This is mass. Mass has a unit of kilograms, kg, times d, distance. Distance is measured in what? In meters. That is m. Remember there's a power of 2 here. So I introduce the power here as well. All over. This is time. Time has a unit of what? Seconds. So this is s to the power of 3 because of this power we have here, right? So simplifying, we have kg m squared, right? This slash here is division. This is times. Then 1 over s to the power of 3. Because this can also be written as kg m squared, right? Times, okay, kg m squared times 1 over what? S to the power of what? 3. 1 over s to the power of 3, which can also be written as what? Kg m squared. 1 over s to the power of 3 can also be written as what? S to the power of minus 3. So you can choose to do this by jumping this step. If you like, you can jump this step. From here, you get your final answer, which is the same thing. Any which way you go, as far as you're doing the right thing, you're going to get the final correct answer. So we have it as kilogram meter squared per second cube. So from the options given, the correct option is option B. Okay. So I've been able to do a recap from question 1 up to question 3. If this is your first time coming across my page and you like what I'm doing, please kindly support me by by subscribing to my channel and turn on the notification bell so you get notified anytime I post a new video here or anytime I'm live on this page. So if you have any question and you're still with me, please kindly drop your question in the chat box. Then I move on to explain the last question we solved tonight, okay? So I can explain the last question we solved. We are solving problems under units and dimensions. Okay. Help me tap on your screen. The more you tap, the more audience we have coming to watch this live. If you have anyone preparing for any external exam, be it WASE, NECO, or JAM 2026, kindly invite them to watch my live sessions because I'll be solving past questions. Okay. Okay. I have about 4 minutes to end up this live, so I'll use the remaining 4 minutes to have a quick recap of the last question we solved. The question says, the period t of oscillation of a simple pendulum depends on the length L and acceleration g. Determine the exact form of dependence, right? So the first thing we do for a question of this nature is for us to establish a relationship between or a relationship between the given quantities. The quantities given in this question, we are given period t, the length L, and acceleration g. So we establish the relationship, which is t is equal to L times g. But we have to introduce the constants x and y. Okay, so we have to get the values of x and y so that we make comparison between the left hand and the right hand side for us to be able to get the exact form of the dependence. So we establish the relationship, which is t is equal to L to the power of x, g to the power of y. Okay, so now we know that the dimension, the next step is to introduce the dimensions. That's what I did here. The first quantity here, which is t, the dimension for t is t. Dimension for L is L. The dimension for g, acceleration, we don't know yet. So what I did was to introduce the units for acceleration. We know that acceleration has a unit, SI unit of what? Meter per second square. So meter has a dimension of L. Y second has a dimension of t. So this is what? LT to the power of -2. Right? So now we've established all the dimensions for the given quantities. So what we do next is to do what? Substitute. Going back to the established relationship, which is t is equal to L. Usually dimensions are in an enclosed bracket. Please don't forget, we put our dimension in an enclosed bracket. So we have the L, which is this L, then the power of x. Then for g has a dimension of what? LT minus 2, which is what we have here, LT minus 2. But remember that the g has a power of y. That's why we have the y here. And this y affects all of the dimensions for what? Acceleration. So this L has a power of y. That's the next step here. You see the L to the power of x, right? Then we have the L also. The second L, that's for the one under the acceleration. L to the power of y, t to the power of -2 times y is -2y. Okay, so we can decide to put the whole of this in an enclosed bracket. So this becomes what? L, now the bases are the same. From the laws of indices, if you have a to the power of x multiplied by b to the power of y, this is the same thing as saying what? A to the power of x times a to the power of y. From the laws of indices, if the bases are equal, you pick one of them and you sum up the powers. So that's the same thing we did here. L to the power of x times L to the power of y is L to the power of x plus y. Then we have t to the power of what? -2y. Now, if you look at the left-hand side, the right-hand side, we have the dimension of L, we have the dimension of t. But on the left side, that's on the right-hand side, but on the left-hand side, we only have the dimension of t. We do not have the dimension of L. So that's why on the next step, I introduce the dimension of L. This dimension L has a power of 0. And we know that in mathematics, a to the power of 0 is equal to 1. So this L to the power of 0 is 1. 1 times t to the power of 1 will still be t. This t has a power of 1. So introducing the dimension of L to the power of 0 doesn't change any value. Right? So this is L to the power of 0, t to the power of 1 is equal to L to the power of x plus y, t to the power of -2y. So what do we do? From our knowledge of indices, we just equate the powers. If you equate the powers, what happens? You check for L. L has a power of 0. But on the right hand side, L has the power of what? X plus Y. That's, you call that your equation 1. Now, looking at t, t has a power of 1. You equate it to the power of t on the right hand side, which is minus 2y. You solve. We have equation 1 and equation 2. So you solve simultaneously. From our knowledge in maths, you solve simultaneously and get your values of x and y. We got x to be 1 over 2. We got y to be minus 1 over 2. So we go back to the relationship we established from the beginning. This is the relationship we established. So what did we do at this point here? All we had to do is to do what? Substitute the values of x and y we got. X is 1 over 2, and then the y is minus 1 over 2. What do? I explained something here that a to the power of 1 over 2 is same thing as square root of a. So L to the power of 1 over 2 is square root of L times, if you have a to the power of minus 1 over 2, this is the same thing as saying 1 over a. All we are just doing here is our basic knowledge in what? Indices, right? So this is what? Square root of L times 1 over square root of G. So we have t is equal to square root of L times 1 is square root of L all over square root of G. So they both have the square root symbol. So we just introduce the bigger square root and put the quantities in one square root. Thank you so much, Adiola. Thank you. Your words of encouragement, it means a whole lot to me. Thank you so much. Right? So our final answer is what? T is equal to the square root of L over G. So this is the final answer. This is the what? The exact form of the dependence, which is what we are asked to look for. As simple as that. So I've been able to solve 4 questions on that unit and dimension. In my next live continue, I'll pick another interesting topic in mathematics. Thank you all for your audience. Thank you all for your contributions. If this is your first time, please kindly give me a follow, please. Kindly subscribe to this channel. It's a way of supporting me. Thank you. So we spent the 1 hour already, past 1 hour in fact. Thank you all. Have a good night, irrespective of a geographical location. I'll see you next time. Bye-bye.